Welcome, everybody. This is going to be part two for the Module 6 lecture. And last week we got up through slide 43, which is about halfway through. We're like really close to exactly halfway through, actually. And we hit this point and then we decided to call it a night. But today we're going to pick up right here where we left off. And we're going to start by doing this try it out exercise. And in the process of it, try to recall some of the things that we learned last week and then hopefully strengthen those concepts as we do the work. All right. First thing I want to do is kind of read through this, and it says create a program that has a second class named pet, right? A pet should have two properties. And actually, I should backtrack to that first bullet. What do they mean by a second class? Like it's not as good as the first class? Right? You guys picking up on the language there? Now, remember when we're working in Visual Studio and we expose the entire namespace and the top level statements, right? So we're starting to see this stuff now. Well, the program itself is a class, right? So when they say a second class, well, I can either do that, right? And we've done this already where I can create the class file here, or I can create the class file externally. And last time when we did the example, we did it internally, right? So we just basically just said, class and what they want us to do is create a class called pet, right? So I could create it right here, right? And then my program code up here in the main method, and in fact, and the rest of this class up here can access that because they're in the same file. But this time, what I'm going to suggest that you do is to instead, start to, get comfortable using one of the really common techniques that Visual Studio people use a lot, right? So when you build applications and you're adding program files and other components to your application, the real common way to do it is to use the Solution Explorer, which is this little panel up here in the top right that, and I want to be really cautious about how I describe it because the gut instinct is to call it like a file manager, but in reality, that is not at all what it is. And I want to show you what I mean by that, because if you look, and I know this is very small on your screens, for example, I have the program.cs file, and you notice how it's got a little expander arrow next to it. If I click on that, you notice that, it's got program.cs and it's got, there's program there. Well, that relates to this program class right here. And then if I expand that, you'll notice, there's a main method inside there. So all the pieces of the application, in other words, the main components of the code are expressed in the Solution Explorer. So it's really a hierarchy of your code structure and sort of a file manager too, right? Because program.cs really truly is a file. And now we want to add a file. So the real common way to do this in Visual Studio, by the way, is, you can go up here and go, file, new, and then choose what you want to create. But the more common way that programmers do it is they just come into this panel and then right on top of usually the project, right, they'll right click and they'll choose add, and then they either choose a new item and get this interface and dig in here for the thing that they're looking for, or when it's really a common activity, like adding a class file, which is basically a program file, you just come in here, right click, add, and then choose a class. Anything that you choose from that other interface and you use a lot will pop up on this list after a while as, towards the bottom. Like, so if you, build a bunch of different things very regularly, they'll kind of appear and be quickly accessible. So if you go ahead and do that and create a class file, that dialog still comes up because they want to make sure that you know what you're building. But feel free to kind of poke through the menus here and notice like some of the things that you could potentially add, including things that make no sense for what we're doing, but all sorts of stuff in here, right? We are going to build a C# class file, right? And then if you wanted to really to dig in, to look at very certain things, for example, you can kind of look in categories and find the stuff that you need. We are just building a generic C# class, and here you can name it, and I'm just going to name this, what do they want to call it? Pet. Right. So we're going to create the pet class, and we're going to add it. And then you'll notice as we create that pet class, it now is also called an internal class called pet, right? The internal access modifier, this is technically what this is, isn't super important that it's there. So I could, in principle, get rid of that and it'll work just fine, right? There's no reason to actually remove it. I also want you to notice that the class ends up sitting inside the namespace that is shared by all the class files in the project. So it's possible that your program has more than one program file. That's okay, right? And in this case, pet is going to be a blueprint file, right? It's not going to be an executing file, so it's not going to have the main method, but it will have the class definition of what we're building. And then we're running the program.cs file. This will be able to access pet because it's in the same project inside the same namespace, and we just refer to it and it will be drawn in. Okay, so that's kind of the mechanics, right? So we had one example last week where we were building the class file internally, and this week I'm going to do at least a couple where I'm doing it externally, and I think it's good practice. Generally, my opinion on it is, if you're building a class file that's a blueprint, why would you want to embed it into a program file? It makes much more sense for it to be standalone. All right, let's go back to the PowerPoint and look at the properties here. And it says a pet should have two properties, a string called name and an int called age. And somewhere on my screen here, I think I have these already set. So I'm going to come back over here and I'm going to add those two things. So I have a string called pet. Notice the question mark there, just so we don't get a failure. And an int called age. Both have the get and set properties available to them, meaning external to this, we can set and retrieve that data. Now, normally, like if I'm creating a class file and I want it to be accessible, typically, by the way, I would type public here, and that's okay to use that if you wish. Internal is generally considered a little bit safer, right? That would be internal to this namespace can only access it. Right, so that was step one. In the main method, create two objects that are instances of pet. Set the name and age values for each object and then print out the values. So if I'm going to do that, and I want to have you think about this, where exactly am I going to make that happen? Because this doesn't have a main method, right? It's probably a good idea for me to save this. So let me go ahead and save that file. But back over in the program CS file in the main method, this is where I would instantiate the pet. And I'm trying to use the terminology that goes with it. So for example, if I want to create a new pet, and notice how it finds it because it's part of the namespace, right? And what I would suggest is, like, if you do have a pet, whatever, I have a dog, so I'll name this pet dog. And we'll use the new pet constructor. So that's going to reach in to that class file and build me a new pet. What is the name and the age of the pet right now? Nothing, right? We just built an empty pet, right? We didn't specify what that should be. If I want to set the properties directly, the data fields, that is, right? And I'm trying to use all the different things. I called this object dog. And now, and notice the IntelliSense kicking in here. I want to name that dog. I can just choose it from the list. Where's that pulling it from? The class file, right? And no, I don't want to call the dog test. I'm going to call my dog the name my dog actually is, which is Abby, who's sitting right by my feet here, right after I spent the whole day outside with me in the backyard. Right. Next, we're going to give the animal an age. And, I really don't know exactly how old she is, but I'm going to speculate 10 might be right. I'm thinking she's more like 9 years old. We didn't get her when she was a puppy. We inherited her from a neighbor who passed away. All right. And then we can prove that the dog was created by just simply doing a console right line of the name and console. So fumbling with that one.
wctc.
Yeah, thank you. I was hoping that it would fix it automatically for me. Sometimes you lean on that a little too much, right? And it said create two objects that are instances of pets. So that's one object, right? And now we're going to create another. Um, so let's do another pet, and this will be, well, we have more than one cat, so I'm going to call this cat one. And cat one, his name is Mojo. Literally found him as a kitten on in the inner city in Milwaukee, driving by. I saw him on the sidewalk, stopped, scooped him up, and took him home. One of our favorite cats, by the way. And then his age, well, he's about 2 years old now. And then we can do the same thing. I love the autocomplete because that's exactly what I would type. Right. But really important conceptually here, right? The class file is a separate file. We're setting up a class called pet. We're giving it two data properties or fields, if you will. These are both set to public, so we can get and set externally. And what's really nice about that approach is that I can very easily, just using dot syntax, set a value and very easily retrieve that value using the same syntax. Very clean, very simple, very powerful. All right. Let's go ahead and run this and prove that it works. You guys should do the same. There we go. Abby is 9, Mojo is 2. You know, and you could add more verbiage to it if you want to prove that it works. All right. So there's the try it out, and I'm not sure if I completed all the tasks and print out the values. Okay, so we managed to do that, and I strongly suggest that you guys do the same thing, you know, as you're following me here. All right. Okay, so they're asking here, says, what if we want to print a rectangle's name in our driver class? Think about scope and private access rules. The same visibility restrictions apply if we want to read and print a field's value. We need to write a method that returns the value. So now what I'm going to do here is, because, you know, maybe I shouldn't have combined files, but I can open up my previous solution. Actually, maybe this is the better way to do it. All right, so this is where we go back to the rectangle thing. And what they're trying to mention here, right, is this access modifier. This class is set to public, but these data fields are set to private. And if you guys recall how we learned about this, right, that means that I cannot use the same approach that I used here, right? So I can't directly access name and age both to set it and to get it. With the private approach, right, I have to use methods to do it. So I can create a method inside the class that has access to it internally, and then I can make that method public. So external from the file, we can make it work. And if you guys recall all that stuff and how we kind of designate it. Another thing that we talked about is this convention, and right, not a rule, but a convention that we put an underscore in front of private variables so that we can easily identify them. You know, so when we look at them in the code, we're like, oh, that one's private. Very easy to spot. Right. So that's one of the takeaways from that. Um, and the whole process of kind of creating those methods, right? Once again, right? So we look at the code here from the high level. So we have a private string called name. So I can't change it from the outside, but I can run the public method, which has access to it, right? Just to reinforce the concept. Kind of an interesting approach because there are times we do want to protect our data. Um, then when we use the get name method, right, we can very easily extract the information. So now if I go back to that particular program once again, and I'm just going to kind of repeat some of the stuff we've already learned, right? So for example, we were able to set width and length of kitchen, right? Because length was originally um, a property that we had to get and set, right? And then notice that we eventually changed that, but we can remove that aspect of it. So if I ran this right now, would this work? I guess this is, my question. Given this information, if I say kitchen dot width is 20 and length is 15, can I set the length directly like this? It's not putting up an error message. You guys notice that? But can I do it? Well, keep in mind now, because I changed this to a capital L, it's not referring to this, right? But if I tried, so I'm going to just give you the example here. If I did underscore score length, would that work?
No.
No, it would not. Right. And this is really kind of the grand point. So we switched from that private variable to what we think of, and it looks like it's like a method or something, but it's not. It really still is a data property, but we're expanding, the detail of it. So forget, we're not just saying, okay, you can get and set, do whatever you want. We are going in there and saying, well, you can do a get, but really what it's returning is the private variable, kind of like the method was doing. And then when you do the set, well, we also have to make sure that, well, we can set it, but the value's got to be greater than 0 because it doesn't make sense to have a room with a negative length. Not at all, right? Same thing with width, right? Width, however, and notice that one we kept. So that one, in principle, I can still get and set directly because it is public and the get and set are there. I don't have to do anything special. So in truth, width, I can will operate just the way pet did. Length, however, goes to this, altered version, which then has access to the private variables, which really truly hold the data. Right. So that's kind of the reinforcement of some of the knowledge that we put in there. Now, when we use the get name method, right? So we did set up a get name method here, and that has access to the private variable. And so if I want to extract that piece of information, I have to call get name. If I want to set the name, I have to use the set name method. And that's really what we're kind of reinforcing here, right? So this is some stuff we already did, but we're applying labels to it now. So that's really, like, why is he talking about this? We already did this, right? Well, what we're talking about really, truly is kind of these definitions where we call things accessor and mutator methods. And this is kind of fancy terminology, right? But let's kind of read through this so you kind of get the gist of it. Having private fields and public methods to retrieve and update them is extremely common, right? So setting stuff to public and allowing people to just willy-nilly get and set like I did with the pet is not the normal way to do it. We don't want like somebody like a user, for example, lowly user, using our program to like be able to change data for things they shouldn't really logically be able to do. That's why we do that. Right. So Methods that return a field's current value are called accessors or getters. The ones that update something are called mutators or setters. Now, the way that I learned, we always called them getters and setters. That's the way I learned, right? But depending on what language you learned and how long ago you learned it, some people also call them accessors. But think about it, like you're accessing the data or you're getting the data, same thing. Or if you're setting the data, that means you're changing it or mutating it. So accessors and mutators or setters and getters, right? And those words are kind of used interchangeably. All right. When we start talking about the properties, right, and those typically are the data fields, right? And it says properties are specialized members in C# classes that allow for ease of storing and updating data while securing all the data from direct access. And the example that we had, right, like for example, if this is public, right? So no setter, no getter or setter is needed. It's built into the object. Class is public. The property is public. Piece of cake, right? But if you want to secure your data or maybe obscure your data, data hiding comes into play. And it's really kind of, as it indicates here, a foundational concept in object-oriented programming, because does it really matter what data is inside of an object if it just works for your purposes, right? Like once again, I'll use the example of the internal combustion engine. Do I really need to know how like a camshaft works in order to drive the car? It doesn't really matter as long as it works, and we can hide certain pieces of information from the outside world that keeps the program working correctly. And then we can allow access to the things we need to allow access through the public definitions. And therefore, as it says here, it puts the programmer in control of what's going on. People can't willy-nilly change stuff. If you have certain reasons within your organization or business for doing things a certain way, and the example, no negative rectangle dimensions, duh, right? I don't want a negative shaped room. It'll put me in a different dimension or something, right? Yeah, that makes no sense. And you're concealing the stuff on the inside, how it's built, right? So for example, like we learn how to use strings, you put double quotes around text, and then later on you learn that, well, a string is really a class structure. It's actually a list of characters, and it's got a bunch of methods that go with it, like to upper and all these like weird things that we do with strings. Think about it, right? That we really don't care about. We just want to get the string on the screen or capture it from the user, right? We don't think about the fact that a string is actually a complicated class structure with its own methods. We don't think about it at all. We just use them, right? Right. So that's a really good example. There's also this concept of what we call stale data. If you see the little subheader there, and as you kind of like read through this, it says the rectangle class doesn't have a field to store area, right? So if I look at the rectangle class, which we defined here, right? So we have name, length, we have width, we have the public length and the private length. Then we have a set name and a get name. And we really didn't write an area thing. But if I wanted, I could very easily create this code, right? And I'm just going to copy it, by the way. Right. And I can add to my rectangle class this method that I can call upon, and then it uses the internal data of the object to calculate the area, right? Because if it's got a length and a width, the area is kind of a given, right? Right. It's kind of built in to the object. And notice though that the code doesn't actually store the information. It just does the calculation when it needs to, and doesn't store it at all. So if this returns a value, where is it going to get stored? In the program that's calling it is the answer. So some pieces of information I don't need to store because it's the result of a calculation. If the program calling this method needs to store it, well, yeah, go ahead. We don't need to store it. We're just giving you a number and you can move on with your day, right? So it's about efficient memory usage partially, right? So you're not storing the information, right? So if I want to get the area of the kitchen, then I can very easily drop that code up here in the functional program, right? And I can run it. And when I run it, the very last output, oh wait, okay, now I'm running the wrong one. All right, and this is the problem with opening up all this stuff here. All right, let me close the solution and then reopen it. And actually what we want to do is we want to open the whole solution. So let's do it like that. Let's open project or solution. I just opened a file is what I did last time. And those are my gateway files. There we go. And the one we want is module 6 examples. All right. And we'll open that solution file, and that opens the rectangle class and program here that I can now execute. So now when I run this, you will see the correct output. So the area, so 15 times 15 is 300. That's correct, right? And I'm not storing the value. Once again, that's kind of an important takeaway as well. Value is not being stored. Could I store it? Sure. I could just very simply, if I wanted, I could just create, I suppose the result of the calculation is probably an int or a float, right? I could make it a double, I suppose, and just call it area. And then I can just take this command, drop it here. That's going to return the area. And then I can just output the area. Right. So you can do it that way. And now the external program is storing the data and then printing it. But that's kind of the point, that do we need to store it? What are you doing with that number? Are you doing more math with it? Well, maybe if you're trying to get the total square footage of the house and you're adding all the rooms together, maybe you would store it, right? But in other purposes, you would not. Another thing that we could do, and this is really kind of a weird approach, is we could actually create this as a property. So this is kind of an interesting thought, right? So instead of creating it as a method where I call get area with parentheses and it does the math and gives me a value, I could also create it as a property and do this, right? So what I'm going to do here is I'm going to just change this. So what we're saying is I don't need to do it this way. Instead, what I can do, and I think this is kind of an interesting approach, I can add it as a property up here, and I can just copy the syntax. And you don't have to spread it out quite so far. In fact, I think what a lot of programmers prefer to do, real frankly, is this, and this is probably how I would do it. If I was coding this, I would just put it all on one line. And C# doesn't care, by the way, right? As long as all the curly brackets and everything are okay. So now I'm treating it as another data property. And then I can just say get here, right? And then it returns length and width, just like the method was doing. And if I want to call this now, notice the difference in the call. Now I treat it like a property. There's no parentheses. So when you use like this dot syntax and it's got parentheses on something, well, that's a method or a function. If it's got no parentheses, then it's a property. It's a data field. Now, interestingly, is this getting stored? this is kind of an interesting thought here. Is it getting stored? Or is it just returning the value? And the answer is the latter. It's still not storing it, right? So I think that's really kind of an interesting approach. If I wanted to right line that, I could just borrow that and come up here. And I'll notice how get area is not going to work, right? So we can just drop in this statement, and then that will work and still give us, the same value. And actually, that's not the correct math, is it? What is it multiplying? 20 times 15. It just dawned on me that we weren't looking at the right math. All right, moving on here, folks. So let's go to the concept here that we're trying to hit upon here, which is this concept of stale data. And think about the questions we're being asked here. Could we have a field for the area? So could I just create a data property that contained the area? And then they ask the question, should we? I mean, is that appropriate? And then it says here, how would an area field have gotten its value? A setter of its own, or is it recalculated whenever length and width are updated? So this is one of the reasons why you might not want to store it. So the concept really is returning the freshly computed area prevents it from becoming stale or outdated. Because like, what if all of a sudden, I'm working with a blueprint, right? And I say, well, I don't want my kitchen to be 15 by 20. I want it to be 17 by 20. And if the area is stored, now that data is stale, right? Because I can dynamically change the size of the kitchen if I wish, especially in the blueprint phase, right? Before we actually build it. So this is what we mean by stale data. So in some cases, it's better to calculate a value rather than to store it, right? A couple little notes that they have here. Getter and setter method should only do one job, right? So you either return information or you set the information. And notice here, it says one line of code in the body usually suffices. So they're saying, don't write something like this. Now look at what they're doing here. When you set the length, it comes in as a double. We take that and we store it as X, and then we take X and we store it in length, and then we return X, Y. Why not just go directly to setting the length? If that's what you're doing, just set the length and be done. Doesn't need to return anything. One line of code usually works. All right, so going back to the concept, getters and setters. Getters return a value, right? Often brute force calculation. No reason to store the calculation internally. You can just put it directly in the return statement if that's possible, right? Usually getters don't have any parameters. Why? Because you're just retrieving information. You don't need to send in information to get information. You just ask for it, right? Setters typically will have one parameter, and that will be what we're setting the value to. So if I'm setting the name of my pet or my kitchen or whatever, well, I have to tell it what it's going to be called, right? It just doesn't happen automatically. But one parameter going in, the value gets set, nothing is returned, right? And therefore it's void, right? Here, a double because we're returning a value. Here it's void, but we're not sending anything back. We're just setting a value internally with the object. Little extra thought here. It says if a method or property only have one expression or statement as the body, you can use this shortened syntax. And I'm seeing more and more people like switch to the syntax, and I think it's kind of a neat syntax. And check out how they're doing it. So, for example, if I am, and notice this works with a method or a property that only has one expression. So in this case, this is a method. How do I know it's a method? Well, because right here it says void, it tells me what it's returning, which is nothing. So this is a method. The other way I know it's a method is it has parentheses here. So we give it a name and then a set of parentheses with a parameter or without. But if all this does is set a value, isn't that kind of a neat little shortened way to do it? And notice this little assignment operator, I guess. And normally when I see these indicators, I usually call it a lambda expression, right? And that goes down a whole different rabbit hole. But it's just a very shortened syntax. There's no curly brackets involved. We're applying the name directly. So this is something that I could add to my program, right? So if I could take this and here, if I want to set the name, instead of doing this, I could comment this out and then do this instead. And then that's got an underscore there. So we would put an underscore there. But it doesn't really save you a lot of lines of code, right? Because I could move these curly brackets up here, right? And this is kind of the point. And it still works just fine, even if I do that, right? It kind of looks the same. But hey, if it's just one statement, they came up with this little operator here that you can use. And oh, you're doing the set name as a method. There you go, all done. And I kind of like that approach. I think that's a very efficient way to do it, right? If we're doing it as a property, right? So like I could do that with get area, right? And so with get area, we kind of already did that, right? But notice this approach versus this approach. And is this now a property or a method? You should
Method.
say, okay, somebody said method because it kind of looks like a method, but what it's missing is the parentheses. There's no parentheses, so it's a property. Notice I'm not getting a conflict because this one's called get area, this one's called area. And both work, right? So if I come up here and just copy this and say get area, both of those will work the same. They're doing the same calculation. They have different names, right? I think that's kind of interesting, right? So like, if you want to think of it as area, I think the implication they're really trying to point out here is that this kind of implies that the value is stored, where if you name your property like this, it implies that it's calculated, which it is. It is calculated. All right, let's keep moving forward here. We're going to start looking at constructors. And constructors are methods that are built into all objects so that when we call the new keyword with the class name and a set of parentheses, it builds the object. We did that with pet. We did that with rectangles, right? And by default, it will initialize all the information that is required per the definition of the constructor, right? So that's kind of a mouthful. But if you take a look here at, all right, we were creating a kitchen, we were creating a dining room, we were creating a bathroom, we were creating all that stuff, right? And those are all objects that we've created in memory. And the only one that we really played with was kitchen. But in truth, if I was to, let's say, do these outputs, for example, and these are created even though I didn't use them. And here I say dining room, right? And here I say, master bedroom. It doesn't hate it or anything, but did I ever set those values? So when I run this, what's my output? Oh, zeros, right? So why are they zero? Because they're not set. Remember, like if you have a data field and you don't set it and you construct the object, if it's a number, it goes to zero. If it's text, What is it? No, right? Is that what you're trying to decode? I think you mouthed it, right? No. So if, like, for example, if I come here and ask it to put the name on the screen, right? And we could do did I block that out? Get name? No, get name still works. So if I said, for example, um, I can just copy that whole statement, and here we'll say get name, and I run it. And notice how this is recognizing already um, that it's not good, basically. So let's run it and see what the output is. And it says system func one system dot string whatever. What the heck does that mean? That means you never set a name. Not good. If I go in and I set a name though, so I can do, for example, something like that, but this will be master bedroom, and we'll set name. We can call it kitchen if we want. Here we can use kind of plain text, right? Save that and run it. Now, when I output that, oh, what? Okay, so this is a bad example. I'm going to cut this. What did I fail to do here? That's a method, so it needs the parentheses. Running it, right? Okay, what did it bring back? Well, it did bring back something. It's called null. This just didn't show on the screen. If I drop that other line of code back in and run it, notice how it does pick it up, right? Right. So strings go to null, so do characters. Numbers go to 0 by default. All right. So hitting the rectangle constructor here again, and notice they're kind of doing the example that I was just doing, if you think about it. So create a rectangle, call it whatever, and then we have to set the name, set the length, set the width. All right, that's cumbersome, right? That's like 4 lines of code to build the object, not efficient, right? And so this is why we kind of have constructors, folks. So for example, I can build a constructor function, and I want you just to just ruminate on that just for a moment and look at this code, where basically the method I'm building inside the rectangle class is named the same thing as the class. And then I set parameters with their data types where I can accept those parameters from the external program when I construct the object. It'll receive it, populate the data fields internally, and then I don't have to write all these extra statements here to make it happen. I just call the constructor function or method, and then it builds it. So for example, if I take that code, and this is probably not going to jive well with my variable names, and normally where we put that is usually the first method below the data fields. Right? So I'd put it here. It doesn't like name because I use an underscore, but otherwise that will work. Right. And so we'll be demonstrating this here in a second. Right. And once again, look at the syntax. And it says here, looks like a combination of a setter for name, length, and width with no return type, not even void. So notice it does not include in that spot. It doesn't say void. It doesn't say double or int or anything like that because we're not returning any value. Its purpose is to set internal variables. So it has no return type. It does not need to because the name of the method matches the name of the class, right? Right. And notice must match the class name exactly. Can't be one letter off. Can't make, one start with a capital and one start with a lower. That's not the same. They got to be exactly the same for it to work, right? So when we use a constructor function like this, and there's no parameters going into parentheses, we call that the default constructor. That's the one that automatically operates, right? And it says here, when a class has no constructor function inside of it, C# provides one called the default constructor. It just travels with every object. No arguments can go in. And it says constructors without arguments are often called zero arg constructors or no arg constructors. That is terminology I never personally use. I do know other people do use it. So important to know. So this would be the default zero arg or no arg constructor when you see it like this. New rectangle, empty parens. Now, once you create a constructor function inside of your class, though, notice what it says here. C# no longer provides a default one. So the moment I add this, this is how we build it. So if I try to run this code, it won't compile. In fact, if I go back to Visual Studio now and come up here, notice what's happening, right? All of my constructors, my default constructors are failing now. They're no good. Kind of weird. And if I hover over it, notice what it does. Rectangle.rectangle, string name, double length, double width. And it basically says, you're missing your parameters. Don't you want to add them? It's basically what it's telling you, right? In its own special way. I think it's kind of interesting that, they show potential fixes here. And I don't know if you guys ever play with this stuff, but you can actually, have it sort of populate these automatically sometimes. All right. So if I wanted to use these now, I would have to go through and mechanically add all the information like I was adding here, like this stuff. And I have to put it inside those parentheses in the order specified. String for name, a double for length, and a double for width. All right. I think what would be good, I think we're getting to the point. All right, we just have a few more slides and then we will take a break. And what's kind of weird, right? So if we have this default constructor now and I have to feed that information in, and if I add that, it gets rid of the default one. What if I want to have a default one anyhow? Well, then I got to write one. And this is kind of weird. So if I want to have a default constructor because I don't know what the details of the room are yet, or the rectangle are yet, I could use one with the same name. And this is where it gets a little bit weird, right? So here I've got one that builds it with 3 parameters, and now I can add another one. So I'm recreating the default constructor and telling it what to do when it operates, right? So the name, instead of being null, can be unknown, or maybe TBD or something like that, right? To be determined. And then the length and the width is set to 1. I'm not really sure why they chose that. I think it would make more sense to set it to 0, but whatever. They're setting it to 1. So then I'll give you an example here of using both approaches. Now notice how these now work, right? They work just the same way they worked before. But if I wanted for the dining room, I can call it dining room, and then I can feed it a length and a width. So maybe it's like, I don't know, 15, and these are all doubles, right? So 15 by 17.5, I'm just throwing some numbers out there. And then, of course, if I want to see, like, for example, here, the dining room, right, we would be able to see that area. I'm just going to move it to the bottom here so we know that the last output comes from the dining room. And heck, we could also do this with the dining room. Right, saving it and running it. So the last 2 outputs now, you'll see dining room and its area, right? And So we can build it using the parameters we're throwing in or our own self-built default constructor. This is kind of a very interesting thought. So it allows us to do that. But if I get rid, you know, if I add my own custom constructor that accepts parameters, the default goes away, but I can rebuild the default on my own and have it do what I want it to do. And that's kind of the big takeaway here, and convoluted to kind of get there, but very important, right? Um, Interestingly, they kind of make this point, right? So you do still need to use the new keyword like we do back here, right? When we create all these, right? If you're not sending information in, you still got to say new and you still got to put the parentheses in. And here, what they're indicating is you cannot do this. So I can't just say rectangle, call it box, and it won't be one until I use that new keyword. I can use this syntax. This is kind of weird. I can say rectangle box. It doesn't hold anything yet. It's just empty. It's an empty spot in memory. But then I can use box because we created it to do a new rectangle and give it some things. So you can do it like this. I'm not a fan of this approach, real frankly, but you can do it. Right? Maybe you'll decide, you know, I mean, could I also run that constructor without any parameters? Sure. I don't know why you would do that. It seems like wasted steps to me, but it is doable. Right. Another kind of interesting approach here is this, which we're calling here an object initializer, and it says you can create an object and set initial values with this shortened syntax that calls the no-ard constructor and then sets its properties. And the reason why it works, and it says since methods or mutators modify the data after initialized, they cannot be called within an object initializer. So kind of a weird approach, right? Not a technique I generally use, but notice we do the new rectangle, and instead of parentheses following, now we're using curly brackets and setting the properties directly in this fashion using this syntax. And then afterwards, I can set the name. It's kind of weird, right? Not an approach I tend to use, but it is allowable. All right. We're getting to the point where I think we need a break. We've been going for a solid hour here. So let's do that. Let's do a 5-minute pause on the material. We'll come back and finish out the slideshow. Okay, we're back from break and we're going to move on. And one thing that's kind of interesting is when we do create objects, and I want you to keep firmly in your head, like when we work with strings, they're truly objects and not like primitive data types. So we've already been doing it, right? So it's not actually a new thing. We are passing those things around inside of our program. So we can take an object and throw it from method to method, just like we do a variable. And I think this is really kind of an interesting thought. But when we move an object around, we're not really moving the data of the object. We're actually moving a reference to its spot in memory. So for example, if I have this original variable and then I pass it along as a parameter, they're both still referring to the same spot in memory. And this little example here will kind of help to explain this. So take a look at this candle class that we have. And this is kind of an interesting little class, right? Because a candle has a private Boolean data field called is lit. That means the candle is lit or it's not lit, true or false, right? Is the values for a Boolean, right? It has a method called light, which changes is lit to true. Makes sense. I light the candle, so it's lit, right? If I extinguish the candle, is lit gets changed to false. If I want to check to see if the candle's lit, I run the is shining method, and it just lets me know, is it true or false that it's lit, right? Kind of clever syntax. And very common when we do Booleans, by the way. to ask a question in the form of naming your variable, like is the candle lit, true or false? That kind of interesting. Then I can write a program with a main method that executes, that creates a candle object, right? And then we run the happy birthday function, and notice that receives a candle object as a parameter. So the data type is candle, the object that we created. Then we're just using the letter C to represent it. And then inside here, I take that object and I run the light method. Remember, the light method switches is lit to true, right? And so happy birthday lights the candle. And then we check to see if it's shining, and it should say true. Kind of clever, right? But what's interesting about this, right, is here I'm sending the object in, I'm doing something to it in memory. I'm running its method, which is changing a state inside the object, but I'm passing it as a parameter. And here it's referred to as C, but really it's referring back to the original candle. We're passing it here. And even though it goes to a method to be modified, the original one gets modified too. So even though I have two different names, C and candle, they're both pointing to the same spot as in memory. So this is how objects are a little bit different than regular variables, right? Because it's a memory reference that we're passing here, not the like creating a new variable that's going to have its own value. Like, so for example, if I did like sent in an integer and I added 5 to the integer, it wouldn't change the integer out here that I sent it from. But with an object, it does. And that's really kind of a weird thought, right? And this kind of reinforces it. It is it pointing to the same object as the variable candle? It sure is, right? They're pointing to the same spot in memory. Now they have this little try it out here, and I'm going to kind of leverage this a little bit. And I think this is kind of sort of similar to our lab a little bit here. So that should be interesting to do this one. But let's go ahead and try to build this. It says create a program with a class named ingredient. The ingredient has 3 properties: name, quantity, and measurement. And then create a 3-arg constructor that accepts all 3 values. In the driver class, ask the user for the 3 values, create an ingredient object, and then print out the ingredient, right? And this is kind of a sample of what that should look like. All right, so first things first, let's come here, let's close our solution. Let's just do a new little project here. And I'll call this mod 6 ingredient, try it out, just so I know what it is later. We'll use those top level statements. And then instead of making an external class file, oh, you know what? I'll still do that. I'll just make an external class file. I'm going to right click, add a class, and we need to build an ingredient class. So I'm just going to call it ingredient. Right, and there it is. And then here I want to put in my data properties, and I'm going to do those all as privates, by the way. Right, so I'm just going to drop them in here, and we'll have a name, a quantity, and a measurement. All right, what's the next instruction? Create a 3-arg constructor that accepts all 3 values. And so what I'm doing is I'm using this syntax, and I'm doing this kind of in hurry up fashion here so we can get on with it, basically. And I put it in the wrong spot, didn't I? It's got to go inside the curly brackets, folks. There we go. So there's the constructor. Accept all 3 parameters. Next instruction, in the driver class, so the other program file, ask the user for 3 values, instantiate an ingredient object using the data. So we're going to ask for the values first. All right, so let's go back to Visual Studio. So in the program class, we should probably save this. All right, so Control S to save. And then here in our main method, this is what we call the driver class, and if it helps you, AKA driver class, right? Because it executes is why we call it that. And I have some pre-prepared statements here, right? So you can just prompt for an ingredient, prompt for the quantity, prompt for the measurement. Okay. Then they want us to build an object using those things. So we're going to take the 3 variables that we just captured, send them off to the constructor, and build the object. So here's the code for that. So we're going to build an ingredient object. We'll call it our ingredient. We'll call the constructor. We'll send in the ingredient, the quantity, and the measure that we captured up here. And then, of course, we want to retrieve that information, right? And it says here, all right, instantiate ingredient object, print out the ingredient, right? So we want to like put it back up on the screen. So how do I extract that information then? What's the most efficient way to do that? If you look at the ingredient file, can I just extract it directly? This is the first question. These are privates, right? So do I need to write get methods for all of those? Yeah, that's one way to do it. And so that's what I did last time. And I am copy pasting here for the sake of speed, folks. Right. So I have 3 get methods: get name, get quantity, get measurement. Right. Then I can go back to, after I save this, I can go back here and then very simply and quickly drop in these 3 statements to pull the name, quantity, and measurement back out from the object. All right, so if I save this and run it, we'll get prompted. And maybe the ingredient is sugar, quantity. Oh, that's not spelled. That says quantity. Something. I got to fix that. So quantity is, I don't know, 2. Measurement is maybe tablespoons. Right. And then sugar, 2 tablespoons, comes back up on the screen. So I feel compelled to fix that silly error. All right, so I'll fix it for the future. There we go. Right, but that's an example of what we're doing here. But it is possible to interact with your user and grab information and then feed it into whatever object you're creating. Not a big deal to do it, by the way. There's also this concept with objects and classes and methods called overloading. And check out this description here. It says 2 or more methods in a class may have the same name. That's kind of weird, right? Because when you learn about functions, like you can't name them the same thing. You got to be unique, right? Then you put them inside of a class and I can name them the same thing, provided that their parameter lists are different. So they have a different number of parameters or different types of parameters. And the example that we see here, one of the methods called add accepts 2 integers. The other one accepts 2 strings. And think about this. This one returns an int. That one returns a string. When I add 2 integers together, well, I want to return an integer, right? If I add 2 strings together, well, that's called concatenation. So I can return the string, right? But the fact that I have 2 different methods with the same name, they also each have 2 parameters, which is weird, but they're different types of parameters, which makes them unique. So If I call one of those methods inside the object and I send it numbers, for example, the method has to figure out, or it says C sharp, must figure out which add method to call. And that process is called binding. Like, which of the methods am I going to bind to? Well, how about the one that takes numbers as a parameter? That's the one we want to bind to, right? That binding pattern is called a signature, right? And so, it figures out on its own, like, is it the right number of parameters? Is it the right data type? All right, I'll take this one because it fits. Can't put the square peg in the round hole, but I can put the round peg in the round hole, right? Because it fits and it matches, right? When things aren't part of the signature, right? If for example, you know, this approach, right? And I want you to notice here, it says things that aren't part of the signature is the return type. That's not looked at. They don't care what you're returning, right? The access specifier, whether it's public or private, it doesn't look at that either. Um, and then the parameter names, it really doesn't look at those either. They're not really part of the signature. All that it's really looking at is the data types and how many parameters there are. That's kind of the point of that slide. You can overload your constructors as well. Like, we've been kind of doing this already. So like, when we have a default constructor that we build on our own, no parameters, and then we call it overloading when we send more than the default, which would be like this approach where we send in 3 different things. That's called overloading. Overloading is kind of an interesting approach because what happens with overloading is it allows you to set up multiple ways to accept parameter lists and then adjust to all of them, right? And it indicates here, it makes the classes a lot more versatile. So if you have a class set up with a constructor that accepts no parameters, 3 parameters, 2 parameters, 1 parameter, or whatever, you can just kind of send whatever to it. As long as you send it in the right approach, it will work. So you can adapt. It's very adaptable, basically. And it says consider a bank account class with deposit and withdraw methods. One pair that takes strings and one that takes doubles, right? And it keeps all the conversion stuff basically internal, so that like users don't have to worry about that stuff, basically. And here they say modify the ingredient program to include an overloaded default constructor. And the simple way that we can do that, by the way, is just to give you the idea, right? Our constructor right now takes 3 parameters, but if I put one in to replace default, since it's now gone, right, and I drop it in right here, so now this is the new default. This one becomes the overloaded one, right? And really, I could write another version as well. Maybe I just write one that just takes the name. So I could do that. I could create one that just takes 1 parameter and sets 1 value and doesn't even bother with the rest, right? And so now I can send just a string. Now I can send nothing, or I can send all 3 pieces of information. Your choice, and we're overloading. So in other words, we're making it highly adaptable to various types of construction methods, basically. One thing that we're going to start to play with, and we're going to do this in the exercises more so, there's a try it out at the end here, but I think I'm going to skip that for the interest of time, is this concept that when we're working with objects, and now that we have data structures like lists and arrays and those types of things, it's possible to create our own custom collection types. And this is where it gets kind of deep. Because you think of what is an object, right? It's a thing that has data, and it's a thing that has behaviors or capabilities or methods, right? Has both of those things, and they all travel with the object. So, and what's kind of fun about this is if you create a class, you can then create, for example, a list of that type of object. So, for example, I can create a list of rectangles, like I do a list of strings or a list of integers or a list of doubles or whatever. I can create a list of rectangles. And every time I do that, and I store it in this variable called boxes. So this will be a list of rectangles, right? And then, of course, I can construct a rectangle, right? And call it shoebox. And then I can add, this is how we add to a list, remember? I can add the shoebox object to the list. And I can keep doing that. Or if I want, I can also do the brute force approach. This is kind of interesting, where I can create the object with its parameters and add it at the same time. And the way the code works, of course, is the object constructor works first and then it adds it to the list. But this is kind of a popular approach, by the way. A really kind of simple, clean syntax and powerful way to do it. And what's kind of interesting about it then is once I have all this list populated with objects, I can use all the regular mechanisms I use to deal with lists, to deal with those objects. So for example, if I want to iterate through my list of boxes, I can do this. Kind of interesting. And this, if you want to try this, of course, you could add oops, not what I meant to do. You could add a list of rectangles and then just mimic this code. And then you can iterate over, that list of rectangles using this code and get some output. What's also kind of interesting is they have this kind of secondary approach. And if you remember this for populating data fields, right, you can use the curly bracket approach. And I can say I'm creating a new list of rectangles. Notice the use of var here, right? And then I can instantiate rectangles of brute force inside that new list. So it's kind of like, like if I had a list of integers and then inside curly brackets, I just started listing my integers separated by commas. Well, I can do the same thing by creating new objects and putting them directly into my list of rectangles. Pretty wild, right? So now we're creating really, and I want you to think about this, when we create an object, it's kind of a custom data type, is really truly what it is. It's got its own data, it's got its own capabilities. And I can deal with it like I deal with any other type of information or variable in a program, which is very powerful, by the way. They keep kind of like cranking on this rectangle example here. And they show you kind of the approach, right? If you want, the same way that we were capturing information about ingredients and then building an object, we can also build a new rectangle, add that rectangle to my list of rectangles, and then still ask the user for information to set the parameters inside the object using user input. Cool. Right? So even though it's inside of a list, I can still work with it as a regular object. Very cool. Very, very cool indeed. Right? If I want to, add it after I've created it, I mean, I can ask for the information first and then create the object and then add it to the list. Or I can, create the object, add it to the list, and then set its parameters, whatever. Either way, potato, potato, both ways work. It's that kind of flexible. There's a couple of try-its here. And it says modify the driver class to include a list of ingredient objects. I suppose we could probably do that, but I think once again, it's kind of like the homework. So maybe we don't. Let's look at the lab and then we'll make the determination. And then they want you to print them out. Okay. So maybe that would be good practice. I'm just looking at my previous examples. I don't think I went to the trouble of doing that, real frankly, or did I? Yeah, I kind of didn't, real frankly. Yeah, it's not very hard to do. All right. Since it's not very hard to do, let's just go ahead and do it. Um, so I have my class structure here, right? I don't need to really modify this, do I? But back here, I should probably save that though. But back here in the program, if I wanted to work with a list of ingredients, I could very simply declare it. So I could say list, right, of what type? Well, what's the class called? Ingredient, right? So that would be my custom data type, if you will. Let's call it, I don't know, let's call it rectangle. We should do it like this, rectangle list, right? And then, of course, we would say new list and run the constructor and it should build it, right? But do I need to have something inside here? And the answer, of course, is yes. But what is it that would go inside there? Well, what's the data type? Okay, it's ingredient. So we still need to have that piece there. But I know you guys were all thinking that, I'm sure. So now we have this empty list of ingredients. I'm prompting my user, right? I create the object, and then all I have to do, right, is call the list, which is rectangle list, add our ingredient, and it's in the list, and I can output all the information just the same way I was doing before, right? So if I run this, this will still work just the same, right? And what's our ingredient now? Uh, Flour, 1 cup, right? Still works, even though that object is now added to the list, right? Totally works. But the other directive here is to write a loop, right? Well, add ingredient objects to the list and loop until, okay, so I'm not going to do that. That just like seems like too much extra work. When the user is done entering, I guess it's not really that hard to do. So let's look at our examples here, right? If I want to output stuff, could I just borrow this? Yeah, I think we can just borrow that. So this could be our output instead, but we're not calling it box and boxes. All right, how about we do this? Let's call it boxes. No, that doesn't make sense for the example, does it? What did I call it? Rectangle list. Maybe we should call it, that doesn't make any sense. Why did I call it that? The list of ingredients. So what would, right? Like totally not the right name. You guys picking up on that? So what would be a better name here? The list
What
of
ingredients?
say that again, Bob.
Ingredients, plural.
Ingredients plural. Right, correct. Right. And that's a all right. Let's get rid of all this. Right. Because if you're making a recipe, and a lot of us are going to be cooking, right? And you guys have like a special thing you make for Thanksgiving? Yeah, a lot of us do. What I think is really cool is now my kids are taking over the process of making the food. Finally, like they have the stuff that they're making, which is like, you're getting old when that starts to happen. And then here we'll say ingredient. And so, man, I'm just like firing on all cylinders here. Ingredient in ingredients. And notice I'm naming one uppercase and plural. Why doesn't it like this? Because I already have a
Because you
thing.
have a rectangle there.
Yeah. Why don't we do this? I mean, I want to use singular and plural. Why don't I just call it I in ingredients? And then here we'll replace these with I. Then, of course, all these data fields. This is the problem with copy pasting. You know what? Yeah. Thank
It's
you.
rectangle. You got rectangles there, Takis. That's the
Yeah.
problem.
Thank you, sir. This is the problem when you start trying to speed things up. All right, now we also need to match up our data properties, which are name, quantity, and measurement. All right, so, and then we have a get name, get quantity, get measurement. So we're just going to switch our syntax. Get name, obviously not named that though. Here's what I like to do, like when I'm not sure, so I don't have to flip between files, is let the IntelliSense do the work for me. Then we'll do get quantity, get measurement, and I'm once again forgetting the parentheses, but there they are. All right. So we can write a loop now, once again, to contain this piece of it. So let's do that. So I'm going to put a prompt in here. Something like that. And then let's come up with a string variable called choice. And actually, really, we should declare this up top here. Let's declare it here. And let's preset it to yes. Why? Because I'm going to create a while loop here. And I'm going to say while choice does not equal yes or does not equal y. Add the ingredient, quantity, and measure. And then, of course, what do we name the ingredient? Okay, now we're getting in there. But here's the thing: if we don't know what to name the ingredient, and this is kind of an interesting thought, this is where we can strike this syntax, and this is kind of where the example was going before, and take the constructor and drop it in here. So it just builds the object without giving it a name, but it's still in the list. And then we'll prompt, right? So we'll prompt for the ingredients, add it to the list as an object, and then ask if they want another ingredient. And then we'll end the loop. So will this work? I'm trying to do it really hurriedly too. This is why I didn't spend a lot of time on it. Here's how we find out. Let's try it. I'm just zooming out just a tad here. Saving and running. All right. So, all right. So I'm going to think of one of the recipes that I make. How about okay, eggs. 2. Oh wow. How do you measure eggs, right? 2
Each.
2 pieces.
Egg.
2 measurement egg. 2
like
chickens.
that.
Oh my god, this is funny. Measurement unit. How about that? Okay. Would you like to enter another ingredient? Yes. Quantity or okay. So ooh, it's failing, isn't it? So why is it going to quantity and not ingredients? Oh. Ah, What did I not do? All right, let's stop the execution here. I didn't capture the input for the yes and the no, right? So I'm supposed to say choice equals read line. All right, there we go. Let's try that again. All right. This time I'm not choosing eggs, by the way. Let's just choose something else. All right. How about ingredient? Milk, quantity 1 cup. Yes. Sugar, 2 tablespoons. I'll say sure, yes. How about baking soda? 2 teaspoons, spelled correctly. Then I'm going to say no, and then it repeats all the stuff back to the screen. There we go. Yeah, and I know you guys are squinting to read it, but there you go. There's the output. All right, kind of primitive. Took me a lot more time than I wanted to spend on it, but you know, the kind of the grand point here, right? And this is a lot like our homework or our lab and our exercises, by the way, is this concept of, you know, now we have our own class type, and then we can put that into our own collection type, and we can run programs just the way we've been running them, build the objects, add them to the list, and then iterate through that list of objects and put the details back up on the screen. And can you see, like, from like a data abstraction level, how that's like a higher level activity? Now we don't worry about the mechanics of what builds the ingredients. We just kind of utilize it, right? And the more you do it and the higher level you get with it, the more clear that aspect of it becomes. And it is, you know, referred to as data abstraction, right? All right, so I think we did that. Yeah, so we did all the try it outs, even though I didn't want to, right? But we still did them. And you know what? It was a great learning experience. All right, let's call this a lecture, folks. So I'm going to stop the video here. So this video is officially